Okay guys, today's video is going to be on PoE and Lightning, and I'm going to give you a demonstration of my idea on how to address the problem and how the PoE works. But first, let me just kind of give you a brief overview of my situation. This is just a stupid little sketch showing this would be a building, a main headquarters building, and basically we have these Cisco switches and all of these PoE powered Voip telephones all across the building, and they are connected with a normal Cat5 cable. And the problem is that the building is essentially surrounded by trees, and anytime one of these trees that are anywhere near the building get hit, it takes out several of the phones and the switch ports on the Cisco switches, and it just goes through them like nothing. And it doesn't matter what kind of surge protectors you put. I had surge protectors on everything on both ends, and it'll just go through them like they're not even there. So I kind of really got into researching about Lightning and the surge protectors, and it's a really gray world, and for the most part nobody guarantees anything about Lightning, especially if you take any kind of direct hit. So they kind of beat around the bush and kind of imply this and that, but what I found out is that the dirty little secret is that most of the things that you would do to do the normal surge protection are actually make you more vulnerable to Lightning than not. So anyway, the definition of insanity is to keep doing the same thing, expecting a different result. So instead of just continually just putting my faith that the phones are going to get blown up on a regular basis, I want to try something new. So this is what I'm going to try, and I'm just going to go back to the basics and see what I can come up with. But if you look right here, I think this is kind of what it started me off with is that I see each one of these lines coming out with this current, this PoE current that's being supplied by the central 48 volt supply here. I'm going to consider all of these pre-tensioned circuits. That's what I want to call them, pre-tensioned circuits. And I think what's happening is anytime we get a lightning pulse, that there is a lesser known essentially pulse like an EMP, and that's what's blowing these phones out and blowing the switches out. It's always the same thing. It's always the same symptom, and so I'm going to try and address it in a completely different way. And what I came up with is a way to isolate it and put the 48 volt PoE injection right there at the very last moment at the phone, instead of trying to run all the power through the switches. So let me start off with when I give you this a demonstration here first on these switches. Let me pull this up. This is a common input to a normal device, and I'm about to show you a Wi-Fi device here. And basically they use these center tap transformers to do the mode A PoE, where they sneak the 48 volts on the 1 and 2 and the 3 and 6 over here, and they don't use the other pairs 7 and 8 and 4 and 5 at all. They just wasted copper on half of all the cables going back. But this is kind of like the more standard way that they're in the way that we do it. And what I don't like about it is when you use this 48 volts here, is you're providing DC continuity all the way through from the device all the way back to the switch with one long wire. So let me switch over here to the camera and kind of give you a demonstration. This is right here. This is a little Wi-Fi box, and I'm going to show you right now. I have the cable just hooked up to it, and I have the RJ45 breakout. And I'm going to show you how, if you measure the resistance on between 3 and 6, you'll see it dead short. And what it is you're seeing the primary of that transformer there, and you can do the same with 1 and 2, and that's just letting you know that there is a transformer on the front end, on the input of this device here. So, and this is an old broken one. It's got the white light of death. Let me go ahead and plug it in, and you can see that powered up. I don't think you can see it on the camera here, but it's got the white light there. And I'm using just a standard PoE injection module here. And I'll show you how that works. It's really easy. This is using the mode B. So what they're using is they're putting the voltage on pins 7 and 8, and they're using 7 and 8 for the negative side, and 4 and 5 for the positive. So if I come up here on my voltage and I come over here and I check, there's my 49.6. So, and if I do measure the same on the input here, the LAN input, if I come to 7 and 4 and 5, you'll notice there's no voltage there. So this PoE injector does not backfeed to its source. It only puts that voltage out on the PoE output. So, but let me tell you the thing that I don't like about these standard PoE injectors, and that's this. If you go from, say, like pin 3 to pin 3, there's continuity. And same with 6 to 6, and 1 and 1 and 2 and 2. So it just they're just straight pass through, and it's just DC continuity all the way through. So that was one feature I was hoping I could find some kind of injector that then would also transformer isolated as well. And they do make them, but they're extraordinarily expensive for some reason, and I don't know what the deal is with that. But I found an incredibly cheap way around that problem, and I'll show you what I came up with. But anyway, yeah, this is your, like I said, your standard 48 volts coming in mode B on pins 7 and 8 and pins 4 and 5. So let me disconnect this here and move it out of the way and slide this in here, and I'll show you what I came up with. What this is a super cheap way to get the 48 volts with, as well as getting the isolation. So this is just it's a RJ45 connector here, and the cool thing about this one is it's called a connector with magnetics, and what it is they embed a couple tiny little transformers inside the connector here, so that there's actually isolation between the inputs and the outputs. And so I came up with this little thing here to get not only my 48 volts locally, but also to be able to get my isolation. And so those are the parts. I just put them together here and use a little heat shrink to seal it up. And so it's just meant to go in series. And plug into the wall there. So let me pull this up. And here's the schematic of it. And like I said, what I really like is the fact that we have these two transformers here that isolate our data lines on the input and output with total DC discontinuity. So anything coming this way to get on this side of the transformer has to blast through 1500 volt worth of barrier there, insulation barrier. And so I was like, well, that could really help. And the other thing I found is that having anything to do with ground out here just entices the lightning to come this way and to try and discharge through out here. I don't want any kind of ground anything out here. I want it to be just two pair of transformer isolated connections. The other two pair back here, I snip off at the cable. I don't even want them. I want a large air gap between them and anything to go here. So once again, the lightning would literally have to leap across the air gap and hopefully dissipate a good bit of its energy in doing it. To get any further after it came out of the wall. So in as far as the 48 volt power supply coming in here, and it's given the mode B PoE, and the RJ45 has the two pins already shorted internally, so all you have to do is make the two little connections there. Makes it real clean on the install. But if you actually got hit on your AC mains and the AC outlet that this is plugged into, there's really nothing that's going to save you. It's going to blow this up, and it could probably blow the phone up too, or whatever it is. That's not what I'm trying to do, and that's not what I'm claiming to prevent. I'm just simply trying to make it less likely for that big surge pulse that I'm talking about here to be able to tweak, because when this happens, when this failure happens, it blows out the PoE section of the port, but the data part actually still works. Every one I've had, the PoE is not working anymore, but the data will still work. Now with the phone side, it's always just a dead phone because the power supply section itself gets blown out, and so there's no hope for it. But I'm hoping with this isolation here and doing the PoE locally, that I'm going to avoid that banjo string popping that I think occurs. But anyway, this whole thing here that I came up with is extraordinarily cheap. It's with the power supply, $4, and then like $2.50 for the connector, and then $1 or $2 a piece for the little board, and the half of a 1 foot patch cable here that I'm using. I'll definitely make a follow-up video next fall to see how we did over the season, and it's completely anecdotal, doesn't really mean anything, but I'll certainly be interested to see if the phones keep blowing up with these on them. But anyway, that's the PoE and Ether Lightning video. So hope that helps, and we'll talk to you soon.